Hi, I'm Taeho Lee's AI avatar. From here, I will guide you through the technical story of GeoMet 730EV. Let's start with the market need. In 2024, the EV market in Korea faced a serious safety concern. On August 1st, there was a Mercedes-Benz EQE fire in an underground parking lot. On August 16th, a Tesla EV caught fire while parked on a roadside. These events made people think again about EV safety. Hyundai Motor Company needed one clear answer: no fire, no sparks. To check this, Hyundai Motor Company used two severe tests. The first test was the torch and grit test. In this test, flame exposure and grit impact are applied alternately in repeated cycles. First, the specimen is exposed to flame. Then, grit impact is applied. This cycle is repeated. The second test was a thermal runaway simulation test. This test is closer to an actual battery fire condition. Here you can see the thermal runaway test using one of our existing zinc flake products. It passed the torch and grit test, but in the full thermal runaway test, it ignited. This was the turning point. Even within zinc flake coatings, conventional products could not survive the most severe conditions. So we moved fast. We formed a dedicated task force team. We redesigned the coating. We improved the formulation, and we developed a new product. That product is GeoMet 730EV. Hyundai Motor Company reviewed many possible solutions. There were adhesive solutions, ceramic solutions, metal sheet solutions, and conventional zinc flake solutions. But each solution had a limitation. Some were sensitive to water. Some ignited during the thermal runaway test. Some had a surface problem. Some required a complex process. Some had a material supply issue. And some did not have enough corrosion resistance. Among all these options, only GeoMet 730EV met the three key requirements. First, it passed the thermal runaway test. Second, it met Hyundai's specification. Third, it was possible for mass production. The message is simple: one test, many solutions. Only GeoMet 730EV passed. Now let me explain how it works. The key is what we call the flame guard mechanism. GeoMet 730EV is not just another zinc flake coating. It is designed to form a ceramic protective layer under extreme heat. In normal conditions, it protects the metal from corrosion, but under extreme heat, it has another role. Zinc, aluminum, and nanosilicon are designed to react and form high-temperature ceramic materials. These include gonite, mullite, and willemite. These materials are very stable under high heat. In simple words, GeoMet 730EV is designed to form ceramic armor, and this ceramic armor helps protect the battery case during a severe fire condition. After the torch and grit test, we check the coating by XRD and SEM. Here you can see the ceramic armor in the analysis results. XRD showed stable ceramic compounds. SEM mapping also showed a concentrated layer of zinc, aluminum, and silicon. This means the designed reaction actually happened under high heat. We could confirm the ceramic protective layer after high-temperature exposure. Next, let's move from mechanism to validation. For automotive use, a good mechanism is not enough. The product must pass the required specifications. GeoMet 730EV passed all key requirements: Torch and grit, pass. Film thickness, pass. Adhesion, pass. Salt spray test, pass. CCTA, CCTC, and CCTF, all pass. This means Geomet 730EV is not only fire resistant, it also provides corrosion protection, it has good adhesion, and it is ready for mass production. Now let's briefly look at each test result. These results were verified by Hyundai Motor Company. In the torch and grit test, there was no ignition on both the flame side and the back side. For film thickness, Geomet 730EV achieved more than 6 micrometers in all measured areas. For adhesion, it met the crosshatch requirement even on GA steel. This is important because GA steel can be a difficult substrate for zinc flake coatings. For corrosion performance, it passed the salt spray test, CCTA, CCTC, and CCTF. CCTC is required for high-voltage EV battery cases. CCTF is required for HEV and PHEV battery cases. Both CCTC and CCTF are conducted on the fully assembled battery case after pilot line coating and battery pack assembly. So these results are closer to real production conditions. Now, some people may ask this question. If future batteries become safer, for example with solid-state batteries, do we still need Geomet 730EV? This is a good question, and our answer is yes. Geomet 730EV has another important value: damage-tolerant corrosion protection. Let me show you what this means. Battery cases can be damaged during assembly. Fastening can damage the coating. Stone chips can damage the coating. The coating can also be scratched or worn during handling and use. So we compared Geomet 730EV with conventional E-coat after each type of damage. After fastening damage, Geomet 730EV showed better corrosion protection than E-coat. After stone chip damage, also better. This is important for future battery pack design. If the battery case becomes more exposed to the underbody area, stone chip resistance will become more important. We also tested other damage conditions such as abrasion and cut areas. The results showed the same direction. Geomet 730EV maintained better corrosion protection than E-coat. Then why does this happen? To understand this, we used SVET. SVET is a test method to see how corrosion starts and moves. Red shows where the metal is losing electrons and corrosion is happening. Blue shows where the metal is gaining electrons and being protected. Green shows a passive state with almost no electron movement. Geomet 730EV quickly forms a stable protective layer at the damaged area. This layer helps stop corrosion from spreading. Another thing we need to understand is whitening. During handling and use, the battery case can come into contact with moisture. When this happens, the coating surface may turn white. This is what we call whitening. At first, it may look like a surface problem, but the XRD results show something important. After moisture exposure, Geomet 730EV forms stable compounds on the surface. These include zinc chloride hydroxide-based phases, similar to simoncolite. Simoncolite is known as one of the most stable zinc-based compounds. Geomet 730EV also forms aluminum-silicon oxygen-based phases, similar to aluminosilicate or ceramic-type compounds. Together, these stable compounds create a new passive anti-corrosion layer on the surface. The key point is this: whitening is not a defect. In the Geomet system, whitening is a passive shield. This completes my technical explanation of Geomet 730EV. From here, the story moves from test results to real production and real business opportunities. And for that part, I should hand over to the real human. Taiho, the floor is yours.